Welcome to the Edge Compute session at SUSECon 2023. My name is Mark Abrams, and for the last 5 years, I've been working as a cloud native field engineer, first with Rancher Labs and now with SUSE. I'm part of a team called the Center of Excellence, and collectively, this team is a bridge between the users of our open source projects and the developers and support teams of those same projects. My colleagues in the COE are masters at the art of what's possible. Since about 2019, I personally have been focused on products that enable and enhance cloud native compute at the edge. More recently, maybe in the last 12 to 18 months, through the feedback and engagement of users and customers, the various edge projects we work on have collectively become a robust cloud native edge solution. And I want to talk to you about that solution today. It's incredible to me how dedicated the people at SUSE are to creating these exceptional technology experiences. We are part of a larger community supporting one another. We thrive not only on engineering great solutions, but also on helping others. And that is part of the DNA of SUSE, which goes back to this company's earliest days. So how do we create exceptional technology experiences? Think about Linux in the early days, an innovative kernel and some utilities used by researchers and computer enthusiasts. The thing that really changed the trajectory of Linux was distribution. There's no question today that Linux is useful. It's a utility used for compute worldwide. But the distribution, the packaging, and the open source communities, this is what made Linux usable. SUSE is much more than Linux distribution. SUSE has been in the business of making useful software usable for 30 years. SUSE is also a company that makes open source distributions of many things. Here's some examples. At a high level, we have 3 base Linux distributions. We have 3 Kubernetes distributions, and we have developed the first open source hyper-converged infrastructure distribution. So when tackling the problem of edge compute, it's no surprise that how we solve this is to enable our customers to build and deploy distributions of their own projects and products. What does an edge distribution look like? Sometimes it's one single computer, and other times it's composed of multiple computers and peripheral devices, sensors, actuators, PLCs, and of course, whatever software you put on it. The edge systems we're talking about are not deployed as single instances. In fact, they tend to be deployed into tens, hundreds, or thousands of disparate sites. Edge requires IoT-like deployment of operational technology. Edge requires the ability to remotely observe, manage, and update the entire system. Edge requires a use case and your business-specific application, whatever that is, to address that use case. Edge is unique to every implementation. So what does SUSE do? What do our solutions look like in order to address these requirements? Some of the features include a tool chain to build the system, central management, common and standardized interfaces, and the ability to automate. The tool chain begins with the Elemental toolkit. An enterprise can not only build the foundation of an edge system, but also customize it to their specific needs. The Rancher Manager gets placed in a data center or the cloud, providing access to hundreds of systems and creating centralized oversight, deployment, and management for edge compute. Kubernetes is installed on the system, providing a common API. It's the same API that's used for cloud native computing. Fleet is a continuous delivery tool, which allows automation of app developments and site-specific configuration, among other things. Edge systems are the production environment of a development lifecycle. And when you have hundreds or thousands of production systems, Leveraging repeatable, streamlined process and automation, it's just critical. Edge compute's been around for some time. Many edge scenarios have sizable compute. However, we often think about microcontrollers at the edge. As we develop a more robust edge solution, we can learn a lot from what we did with microcontrollers. For example, microcontroller developers write code either as a fully baked system or as a set of discrete functional capabilities on top of a runtime. Either way, this amounts to what we call firmware. The SUSE Edge Stack is cloud-native firmware. Cloud-native developers write containerized applications as a set of functional capabilities on top of a runtime. So this is a picture of the general high-level process that enables enterprises to create a cloud-native edge solution with the SUSE Edge Stack. I'll come back to this in a few minutes. I'm going to jump into the provisioning phase of the technical demo. It's pretty simple, but it can take a few minutes for the systems to come up. So I want to kick that off and then we'll take a deeper look at the process. So the first thing I'm going to do is I'm going to create the infrastructure, which gets dynamically configured with the Edge firmware. Then I'm going to set up the specification for configuring that system and providing us access to it. All right, let's go to that. So this is the Rancher Manager. And what you're seeing here is two clusters. The one on the bottom called local, that is the cluster that the Rancher Manager actually runs in. Rancher is an application written in Golang that runs in a Kubernetes cluster. And we can see it here. We can do some of the management of the Rancher cluster itself right here. But the other cluster, the one on top, IAD, this is a downstream cluster, and this represents an edge site. And we can take a look at, in this edge site, excuse me, we can take a look at this from the perspective of Elemental. So we'll go into OS management, which is the UI over the Elemental toolkit. In the middle here, you see I have one used inventory. So one machine that's used. My cluster has just one node. And if it was a 3-node cluster, we would see 3 used inventory pieces. And then on the right-hand side, you see that I have one cluster. That's because the Rancher cluster is not part of the Elemental management. It's not a downstream cluster that we're managing. So we're only seeing our managed downstream clusters in here. And specifically our Elemental managed clusters here. What I want to do now is create another piece of inventory, and we're going to do that. Let's close these here. We're going to do that by going into our VMware and creating a machine. Oh, and I failed on my prep. I failed to delete the old version. So we're going to just do that right now. The machine is running, but not actually connected to anything. So we'll pretend that wasn't there. All right. So what we want to do is create a new site. And so we're going to deploy a virtual machine. We're going to do this from an OVA. We'll click next. Let me go grab the OVA that we're going to use to create this. Let's see. Here we go. And we will call this JFK. Yes, I'm using airports as my distributed my sites. All right, so we just click through. We're going to click next. This is just creating a virtual machine, but it's based on this image that I created. And I'll get into the process in a little bit. But what we will ultimately see is that we have, when that machine comes up, so the virtual machine, it could be bare metal. In this case, it's a virtual machine. We do have customers that use their edge is somebody else's data center. Sometimes they deploy a bare metal machine into those data centers, but sometimes their only allowed to use the hypervisor that's available to them. And so they deploy into a hypervisor, is still their edge. And so they deploy it as a virtual machine. So that makes a nice, easy way for me to demonstrate this. While that virtual machine is coming up, so it's booting and it's going to go through the process that I'll describe. But while it's doing that, let's go take a look at the fleet component. So we've looked at the rancher component a little bit. We're looking now at the elemental component, and we want to take a look at the fleet component, which the UI here is called continuous delivery. And this is the UI over the top of fleet. Now, in Fleet, we see that we have this hello application, and this is managed as GitOps. So this is a Git repository that's pointing to a set of resources that has a deployment and some services and ingress, and it gets bundled into a Helm package and then deployed to every application, because that's what I told it to do. It gets deployed to every cluster that is connected to Rancher. So when we look at this application running on the existing cluster, on this one, IAD, what we'll see is that this application has a service, and we can go to that service, and it's a two-tiered application. It has a JavaScript front end. It's running microservices on the back end. These are running on my edge system. And each time it makes a request to the edge system, what the system does is just responds with some information about the device itself, or the container. So these are the container identities that we're seeing labeled here, and it's just round robining between those and serving up either one. Now, you'll notice that the background on these are purple, and that's the default for the application. So this one application, when it gets deployed, is going to look the same for every site, but sometimes sites have different configuration, and they need to be. We have thousands of production systems that need varying configuration. We're going to make that happen. Let's go back before we do that. Let's go back and look at our elemental overlay. So let's look at the OS management again. And great. Okay, so here's what I wanted to see. We have two machines now. This went from 1 to 2, and one of them is free. It's available. But we only have one cluster still. Why don't we have another cluster here? Well, we actually have to create a cluster. We have to automate. Well, we don't have to automate it, but we are going to automate it. The connection of that physical system with what is in Kubernetes, a custom resource called a cluster. And we're going to do that by applying a Kubernetes configuration. And to do that, we're actually going to create another Git repository. So let's go back and look at our continuous delivery again. Now down at the bottom, you see this fleet local, and we're going to go just into that. And you'll see that we have this downstream cluster 002. We're going to add another one of these. So we're going to do that by applying this file, which is a custom resource definition for how Fleet can find the Git resources it needs to set up a cluster. So we're going to do a kubectl apply -f. This is standard Kubernetes Git repo cluster 001.yaml, and we're going to apply that. That'll create a new Git repository for us. The Fleet system is going to look in that Git repo. It's going to say, oh, I need to go to this location and this path with cluster 01. What's in there? What's in there is this configuration. It's going to pick up this YAML configuration, which has actually two resources in it, two Kubernetes resources. One of them is a machine inventory selector, and the other one is a cluster. And this cluster is going to actually map to the physical system that we just set up in our hypervisor. And there it is. There's the machine getting set up. We can go back to our OS management, and we'll now see that we have two clusters. And if we go back out once more to the Rancher management preview, we see that we have a cluster coming up here. And so let's go through the process. Let's go back to the slide deck. We'll take a look at the process of what's happening that is enabling us to have visibility, observability, manageability, really get into these clusters. So here's an overview of the parts, right? The Rancher Manager is the SUSE solution for multi-cluster, multi-cloud, multi-Kubernetes distribution management. Yeah, it's a lot, right? It really does all that. And it can also help you manage your edge compute with the Elemental stack and fleet. The Git repo resource, the one I just showed you, includes the configuration of my cluster, and it's installed through the fleet component of Rancher Manager, right? I'll show you some more of this in a bit. Next, this set of boxes represents the provisioning process for a device. And this is what's happening with that virtual machine. The virtual machine is going through part of this process. I'll come back to this too. I'm going to walk you through the whole process. Now, these two items are the operations that enable the inventory, a physical machine or virtual hardware system, to become a Kubernetes cluster. These are Kubernetes resource types, and with large-scale edge solutions would likely be deployed via automation. That's what you just saw me do. These configurations are outside the green flow because they can be done asynchronously. I could have done this before we shipped out our VM or our bare metal, or I can do it after the VM is shipped out and turned on. At some point, though, the two need to connect. It's asynchronous. Again, that was the second step I performed. I actually performed maybe a few more than two steps. So a little confusing there. All right. So let's break down the device provisioning process. Prior to the session, I set up a machine registration. Note that this was also a Kubernetes resource. So all of this automated. Using the standard API, I applied this resource to the Rancher management system. The registration, it can help us manage device peripherals, maintain our security posture, and be adjusted according to your enterprise IT OT process for deployment of the systems. So this would have hardware security through the use of a trusted platform module, exposure of peripherals and other non-standard Kubernetes resources, for example, information about serial ports, two-wire capability, CAN bus, etc. What do you have connected to your edge? Depending on the downstream system, there will be indicators in this file as to when the pre-configuration process ends. So there's part of the process can be managed in here as well. Once I have a registration, and I might have multiples, you'll notice in the Rancher Manager we do have a couple. I can make ISOs that bind to our Rancher management plane. Think of the management plane as a digital warehouse, and each physical device is a piece of pre-stack inventory, pre-edge stack inventory. A cluster may have one or more pieces of inventory, and when they're provisioned, we call them cluster nodes. The digital warehouse can keep track of the systems that are in inventory and those that are available to be provisioned. By specifying which Rancher instance should be used as part of the ISO setup, we can manage the supply chain as devices are built, shipped, and operated. Just like any ISO, you can use this ISO image to image bare metal virtual machines, right? So this is just an image, and we can do like we do DD or whatever you use to image your machines. That's how I got my OVA. Once we've installed the stack, we need to register the machines as inventory with the Rancher management systems. That's what I previously suggested is a warehouse, right? This is done automatically on first boot of the machine. That registration information that was baked into the ISO So now it knows how to reach out to the rancher manager and find out more about its role. What is it supposed to do? Here's where we securely identify that the machine, if it's using a trusted platform module, we can securely identify that this machine should be where it is and do what it's doing. If this is a physical machine, it will be shut down at this point and will be ready for shipping to the edge site. So it's just prepped as a piece of inventory and can now go out. If it's a virtual machine, we'll just jump right into the second boot phase. On the second boot, the machine checks in, identifies itself, and we begin installing the Kubernetes distribution. In addition to the Kubernetes distribution, there may be other configurations that get applied. These could be your standard applications or site-specific details. As a bare metal device, this process enables the operational technologist to simply plug it in, turn it on, and have a fully functioning system in a matter of minutes. The same concept applies to the VM appliance. They don't need to know or understand the underlying technologies. The ops team, on the other hand, gets full access to the system and visibility, observability, and manageability through Rancher. This is bidirectional communication with the downstream systems. Developers can simply focus on writing cloud-native applications for this highly scalable and configurable edge solution. All right, let's go check out and see if the system is available now. All right, so it hasn't quite come up yet. This is normal. So the system is going through the process of starting up, and that we will see during the startup process, we'll see that there are errors because there's this talk back, right? Are you ready? I'm not ready yet. I'm doing this process. I'm not doing this process. So I'm just going to poke in here and we'll see what's going on. And we can open up the VM and take a look at it. And you can see Kubernetes has come up. So the networking is getting configured, and that's part of why it's not ready yet, is that it's still configuring its network. Let's see if we return to the command line. Yeah, so it has registered. We can see it has an identity. That's what got set to the host name. Take a quick look back here. Here it is. We were just shy of having it be set up. So the system is up and running now. And we can go into this system and take a look. Let's walk through all of our pieces here, right? So this is the cluster management view. This is the Rancher view. We're going to go down into the OS management view. And what we can see is that we still have our two pieces of inventory, but now they're both in use, right? And we have our two clusters. And then we can go into the fleet view, the continuous delivery view, and we can see that the application has been applied to two different clusters. So there are two clusters ready and two clusters have this application applied. Let's take a look in this particular cluster. So the cluster we just created, the JFK cluster, we'll take a look at the application. It has its own version of the application. We'll go to Service Discovery and we'll open it up. Looks exactly identical, which it should. That's the point here, is that we're replicating things and we're automating it. And it has the purple background. Perfect. All right. Well, in this case, let's give it a green background. Okay. So what we want to do is, and I would automate some of this, but I'm going to, normally I'd automate this, but in production, you'd certainly want to. But I just want to go through and actually check with the system that this JFK that we created, this cluster, is actually a part of the group that's going to get the green backgrounds. So I've created a cluster group called New York, and that's where I call home. And the New York cluster group, this allows us to basically target a specific group of clusters. So we want to look at our cluster and ensure that it is part of that cluster group. Right now we can see there are no clusters in that group. So I'm just going to go in here and modify my cluster. I'll edit the YAML, and I'm going to add the tag, the label that allows it to be part of this cluster group, and that's New York. So this, I'll save this. That makes it part of the New York cluster group, and we should see that now, yep, we have a new cluster ready. But what I haven't done yet is I haven't created any changes to the application to make it vary depending on the cluster group. So we're going to go do that as well. We're going to put on our developer hat. Now this is representing the production side of the development pipeline. So this is the end of the GitOps pipeline. You could have a Git repo that has these changes that were made, tested, right? This is dev, test, staging, production. I have a little process here using a makefile. We're going to make mode 2. And in mode 2, what we do is we apply some changes, and the changes are going to patch this. We have in here something that specifies that the cluster group New York should use the green color overlays. In the green color overlays, we have a deployment patch, and the deployment patch says use green. Now, what I need to do is push this. So I've applied those changes. I'm going to do a git push, and that represents pushing it to my, it is actually pushing it to the Git repository that's being watched by the fleet. The fleet may or may not automatically update. Let's go check quickly. Oh, it already did it. So we didn't even see those swapping out, but basically it swapped out our two resources for the green background. Our IAD one has the two purple backgrounds, and we've basically deployed everything. As I said, the infrastructure, the OS, the whole stack to the edge. All right, let's go back and do a little bit more slides. So edge systems have traditionally had a set it and forget it constraint, with major updates coming every 5 to 10 years. And because of this fixed time and fixed system model, advances in technology are dismissed until the lifetime of the systems expires. And we even generally, we end up building the next system a year or two before we ship it out, which means that by the time we ship it, it's that some of that technology may already be outdated. And all of these traditional constraints create a lost opportunity cost. The SUSE Edge Stack solves these problems by providing a platform that can be continually managed and upgraded throughout the physical device's lifetime. In the old model, device management also requires sending skilled labor to the edge site for even minor updates and repair. The SUSE Edge solution enables remote management, visibility, and upgrades. The SUSE Edge Stack is a model for enterprises to maximize their opportunities at the edge. The SUSE Edge solution also enables you to minimize overhead by providing the tooling and support to build foundational stacks that look and feel just like an enterprise cloud-native solution when it's deployed. This firmware-like approach means your dev teams focus on business application development. Everything below your app is overhead, and at SUSE, we've got you covered. Here's a high-level view of what we just did. On the left side, we have IT ops and developers building, maintaining, and managing remote systems. SUSE tooling plus your app is like having an edge compute production factory. Now, on the right-hand side, we have operational technologists making use of the solutions and making use of the solutions at scale. This is really powerful technology. Thank you for joining me for this presentation on the SUSE Edge Stack. My name is Mark Abrams. I contribute to open source, and you can too.